Hi, I'm Ed Pound, the Managing Director of the Operations Science Institute. Welcome to the Institute's series, 52 Weeks of Operations Science in 2 minutes. To be clear, we're not going to compress a year's worth of operations science into 2 minutes. Every week during this 52-week series, we will provide 2 minutes of powerful, practical operations science insights. If you are not already applying operations science, you're wasting money and resources. Supercharge your and your team's skills with high-value, low-cost operations science online certification. This week is part 2 of our segment on saving billions of dollars in engineering and construction with operations science. We go to the job site for a specific example of how operations science is applied in practice in construction. And hopefully you remember from last week that I'm not exaggerating when I talk about billions of dollars. It's actually a $1 trillion productivity improvement opportunity. Traditional project management creates a plan, assigns tasks, and monitors milestones. But without understanding operations science, mega projects nearly always fall behind schedule and are way over budget. Projects are often thought too unique for operations science. That is just a myth. Here's a concrete, pun intended, example of operations science in construction. On a $7 billion civil project, the work is scheduled to design, fabricate, transport, and install 2,240 rebar cages in 250 days was required. Capacity was planned to easily achieve the schedule and budget. However, without an operations science understanding, the plan was headed toward major cost and schedule failures. If we use our operations science framework, we see that some variation of design, fabricate, transport, and install processes are used for all components going into creation of poured concrete columns. Here's a picture of some poured concrete columns for illustration. Our example is for the rebar cages, which is a supply flow, one of 4 feeding the installation flow, which results in the poured concrete columns. In reality, the fab produced only 10.8 cages a day, and the site installed just 7 per day. Left unchecked, the process would have produced a major cost and schedule failure. A simple operations model of the differences in actual rate between fabrication and installation showed that over 700 rebar cages would have accumulated on site, and there wasn't anywhere to put them if the process had been allowed to run at those rates. The team swung into action, first establishing whip control to ensure the process did not spiral out of control. They used operations science and continuous improvement techniques to improve installation to 9.1 cages per day, and finally they refined their model to optimize whip levels required. The team chose an optimal whip of 20 rebar cages. Why not 14? Because that's where the process curve meets demand. With whip of 14, demand is met on average, but that means 50% of the time demand is missed. Whip of 20 provides some extra throughput padding to ensure demand was always met. The results? The total cost was forecasted at $35.6 million, but the actual cost was only $27.1 million, an $8.5 million savings, and the project finished ahead of schedule. Next week, we start a section on common mistakes and misconceptions in operations science, and our topic will be inventory management. Please join us at the Operations Science Institute. Like, share, subscribe, and comment on this video. Create an account at opscience.org for more great resources. Both the account and the resources are free. Contact us at info@opscience.org for personalized training. The Institute will train and certify your own trainers for long-term sustainability in your organization. Get your own operations science online certification. Share your knowledge and inspire, energize, and sustain success for you and those around you.